Let's go ahead and get started. Good afternoon. My name is Sriram Subramanian, and I'm a Senior Program Manager lead on the imaging and color team on the graphics platform team. It's almost the end of the day, and it's been 3 days of good content, so I'm really glad that you're all able to make it to this talk. To give you a little bit background about myself, I've been at Microsoft since 1998, and I've worked on a variety of graphics technologies for the past few Windows releases, most recently on Direct2D for Windows 7. Today, I'm really excited to talk about a new effects API that we are adding to Direct2D that will help you incorporate cool visual effects in your applications. Here is the agenda for the talk today. First, I'm going to introduce you to the Direct2D effects functionality and give you an idea of the scenarios you can build in your applications. I'll show you a couple of demos to help us illustrate that. Next, I will discuss the key concepts and APIs that you will use to incorporate Direct2D effects in your applications. Finally, I will briefly cover the custom effects functionality support that is available for you to use in your applications. At the end of the talk, hopefully you will walk away with a good idea of how you can incorporate use Direct2D effects in your applications. Let's move to the first item on the agenda. What is Direct2D effects? I have a demo to introduce you to the type of things that you can do with Direct2D effects. So let me move to the demo machine. So here I have a simple photo adjustment application that is built using Direct2D. I'm displaying a 9.5 megapixel image, which is typical size for an image that comes from a high-quality digital camera these days. So notice how I'm able to quickly zoom in and then pan around smoothly. This is something every photo application likes to support, and Direct2D helps accomplish this efficiently. I can also apply other effects here. So for example, I can move my mouse horizontally to adjust the brightness, or move it vertically and adjust the saturation here. Notice how the application is able to track my mouse movement and apply the effect dynamically. And just for fun, I can click anywhere on the image and apply a ripple effect here. And this is again able to apply in real time, and the ripple flows out dynamically at a good frames per second. Let me switch back to my slides. So what you saw was Direct2D effects API in action. It gives you some new capabilities to use in your application. So let's look back at Windows 7 when we first introduced Direct2D. It was meant to be a fast, hardware-accelerated 2D graphics rendering API. It is now the foundation for mainstream graphics applications like the Internet Explorer, which you saw at the keynote and at many sessions afterwards. What was missing was a rich set of image processing capabilities. At the same time, many of you are building applications that need to incorporate visual effects to deliver a cool experience to your users. And today you have a couple of options. The first one is to use pre-built image assets. Oftentimes, you will create them using a tool like Photoshop, which works great for predetermined images or static content, but is but is not quite adequate for dynamic content, where you don't know until runtime what kind of images you're going to encounter in your applications. We wanted to fill this gap in Windows 8 with a fast pixel processing functionality that is built into the graphics foundation. We call this Direct2D effects. They are designed to be fast. All the calculations that are needed to do the effects are all done on the graphics processing unit on the PC. Direct2D effects are designed to work on all the graphics hardware that will run Windows 8, and it is optimized for any graphics hardware that you may have on the system. The other aspect of this is that we wanted to make it easy for you to use this functionality in your applications. Today, some of your apps may be implementing this in a proprietary or a custom solution. This may be a custom D3D solution using shader languages and using D3D concepts, or it may be a custom CPU side algorithm that does image processing. We wanted to design Direct2D effects to be as simple to use as possible. You don't have to be a Direct3D expert or even know what a shader language is. To make it easy to use, we have included a large number of built-in effects that you can use in your applications. You will find that these built-in effects provide a good set of building blocks for achieving common UI and photo effects. Finally, we wanted to make this an integral part of the DirectX family of APIs. So Direct2D effects are well integrated with the Direct2D geometry and text rendering. If you were there at Megastock before, you saw some of that. They are also well integrated with Direct3D and the Windows Imaging Component, or WIC. The last one, WIC, is key to decoding standard file format images from the disk and bringing them into the image effects pipeline. And also, once you have processed those images, saving them on the disk with any of the standard image formats. So once we have this foundation in place, we wanted to take advantage of it ourselves. And so what we have done in Windows 8 is that we have taken this foundation and built IE10 on top of that, specifically support for SVG filter effects and some other features in IE. So I wanted to switch to the demo machine and give you a taste for some of the things you can accomplish with SVG effects. Okay, you have the demo machine. So the first one I want to show you is SVG filter effects on a bitmap that is rendered using the image tag in SVG. SVG, for those of you not familiar, is a W3C standard that's been in existence for a while, and IE9 first implemented support for this. So IE10 now supports SVG filter effects. So in this picture, I can go ahead and apply the saturate effect. This is the same effect I showed in the earlier demo. And I can move the dial here. And you can see this is tracking my mouse and is performing as well as it did in my native demo that I showed before. We go ahead and remove that effect and then apply something a little more interesting. This is a distortion effect that uses a couple of SVG filter effects to create this distortion effect. And I can track the mouse and distort the image to create something fun here. I can do the same thing with text that is rendered using SVG. And so blur is always fun thing and it's a basic thing. So I can move the mouse and the blur effect is applied in real time. And for those of you who have implemented blur using D3D, you know that applying blur involves a lot of calculation, so this is able to do that pretty quickly. Another example I have here is a demo that is taken from a public site. It's called SVG Wow, that has a number of demonstrations of various SVG features. So with the permission from the author, we took that effect, and then the original demo has a bunch of buttons at the top to change the lighting position, and that works very well on the current generation of browsers. We decided to kick it up a notch by changing the code slightly to link the mouse position to the lighting. So as I move the mouse here, you can see that the lighting effect is applied in real time, and this is possible because SVG Filter Effects is using Direct2D effects, which is leveraging the GPU fully. And then here is a fun demo using SVG Filter Effects to apply a burning text effect. And this is accomplished by using a number of effects, primarily turbulence to create the burn type noise, and then applying some color to that, and then applying a masking using the shape of the text itself. And just to prove it to you that this is not just a video playing, I'm going to go ahead and modify the text. So I really meant to say, if I don't make a typo here, SVG filters using Direct2D effects. So to recap, we are leveraging Direct2D effects in IE to provide great support for SVG filter effects. We are also using the same foundation to implement CSS3 effects and HTML canvas effects. In the Metro style UI, Direct2D effects is used to implement nice-looking anti-aliased 3D animations. These are subtle animations that you'll see when you modify when you play around with the tiles in the Metro style UI. And this is just the beginning. In the future, we'll be looking at more ways to leverage this functionality both within Windows itself and other applications that Microsoft builds. And I think that just like we have done with IE, you can leverage the Direct2D effects functionality in your own apps. Use it to deliver the high-quality visual effects that your users will love. Let's now discuss how you can use Direct2D effects in your own apps. There are 3 new objects that you would use. First one is the concept of an image that is an input to an effect or an output of an effect. The second concept is an effect that transforms 0 or more input images to produce an output image. And then the third concept is context. That is a new thing to Direct2D in Windows 8 that I think Mega and Cam also covered at their talks a little bit. That's a new thing that allows you to set a rendering target, and is also the place that for you to call the rendering command. So render the image itself as well as any of the D2D primitives. So let's go into a little bit more detail on each of them. Direct2D in Windows 8 introduces the concept of an image, a potentially infinite plane that produces pixels when asked. An image is an input to an effect or an output of an effect. So it's the currency that connects the various effects together. And then it's also what you will render to the display. It is represented by ID2D1 image interface, which is abstract. The most basic type of an image is a bitmap, ID2D1 bitmap 1. And the bitmap simply returns its contents when it's asked to produce the pixels. We have two other concepts of an image. The output of an effect itself is an image. And then the other image type is a command list. So Megha covered that in quite a bit of detail in the previous talk. But a command list is essentially a way to capture rendering commands for use later, for caching and using later, primarily for printing. It's important to realize that no work actually happens until the image is rendered using the context. The pixel operations are performed only on the region of interest. This enables Direct2D to only compute pixels when needed and only on the pixels that are requested. This is one of the reasons why Direct2D effects are fast and efficient. A Direct2D effect is a self-contained image processing component that transforms 0 or more input images to produce a single output. So I mentioned 0 inputs a couple of times. So an example of a 0 input effect is a turbulence effect. So it's really algorithmically or synthetically generating an image. So the effects utilize the GPU to achieve the effects desired. So they can utilize the pixel shader unit. So most of the effects that you can think of, like the lighting effect or whatnot, are achieved using the pixel shader unit. They can also use the vertex shader. So a common example there is something like a page curl which changes the geometry of the output itself. So it's a little bit of a distortion there that you apply. Or they can use the output merger unit for compositing and blending, or some combination of all three. They can also utilize the direct compute when desired. I'll talk about that briefly a little bit later. While an effect always produces a single output, it can optionally take any number of inputs, such as the output of an effect, as I mentioned, or it can be a concrete bitmap like a WIC bitmap, or a bitmap that was created from Direct2D. An effect can have any number of properties associated with it that adjust how the effect behaves. So for example, a blur effect might have a blur radius that affects the degree of blur. So as I manipulated the text in the example we saw earlier, that was what I was doing. I was programmatically just changing the radius. Or a crop effect, for example, might have a rectangle property to adjust the amount of crop you need. And then finally, an effect can be executed on the CPU. This could be a scenario where the GPU, there is no GPU, like for example, the server rendering is happening on the server. And in that case, it's efficiently rendered on the CPU using the Direct3D Warp software implementation. So as I mentioned, in Direct2D on Windows 7, rendering calls were made directly on the render target interface. For Windows 8, we have introduced the concept of a device context in Direct2D that has both the rendering calls as well as a way to allow you to change the target for rendering. So the interface for that is the ID2D1 device context, and it has the set target, which I will get to in a second. When I walk through the code, that changes the rendering target, as well as all the draw calls that you're familiar with, such as draw geometry and draw text, as well as the new draw image call. To help you take advantage of this foundation, we are including 40 new built-in effects for you to use in your applications. There are several categories of them. The source effects provide a way for you to get a concrete bitmap into your effect. So the most interesting one here is, actually the one in particular that you would use a lot is the bitmap source effect, which is used for taking a bitmap stream that is decoded by WIC and getting it into the image processing pipeline. The bitmap source effect also has several properties to optimize for large, really large images. I see in the audience someone who came by earlier and asked me about how to handle large images, and bitmap source effect is the way to handle that. We have a number of images effects for processing color. I'm really excited to include in this list a color management effect that implements the full support for the latest version of the ICC profiles, including floating point support. This is all implemented in hardware, so this is from a color management perspective, this is the best support for color management that we have had in Windows forever. We have the standard 2D affine transforms, but in addition to that, we also include a high-quality scale, which is also someone in the audience asked me just before the talk started. So I'm happy to say we have high-quality effects in addition to bilinear and the other ones. No effect system would be complete without composition and blending. We have the full set of portrait of blend modes, as well as many of the blend effects that you use through Photoshop. There are a number of lighting effects that you saw in the various demos. And then finally, the histogram effect demonstrates the use of direct compute. So I mentioned direct compute before, so an effect can use direct compute as well. So just like histogram, direct compute will be useful for doing things where you have to process the image as a whole and do computations. So the other example of that will be calculating the average color or whatnot to eventually take that information and do things like increase the visibility of shadows in images or photographs. I mentioned earlier that the input of an effect can be an output of another effect itself. This gives you a powerful mechanism to connect the effects into a directed acyclic graph to achieve the desired visual effect. This particular graph demonstrates the effects connected to achieve a drop shadow effect on a text drawn using D2D. So here, the shadow effect is taking the original bitmap and creating a blurred shadow outline. And then the affine transform is there to take the output of the shadow effect and offset the pixels by whatever the desired amount is. And then finally, the composite effect takes the original bitmap and the output of the affine transform effect and renders and composites and renders the final output. So these effects graphs can get arbitrarily complex. This particular example adds additional lighting effects and more compositing to make a relatively flat-looking bitmap on the left pop out on screen. And when these get really complex, one of the features here is that every bitmap effect supports the notion of caching. So Megha covered that in her previous talk, but to get the most performance out of that, one of the techniques you can use is to cache the output at various points in your graph, depending on the kind of operations you're performing. So for example, if I am manipulating the output at the end of the pipeline, I want to cache anything before that so that I'm not recalculating the whole graph every time I'm manipulating the properties on a particular effect. So using the effects API is super easy. There are just 3 steps that you need to do once you already set up your Direct2D application. First, you create the effect by calling the create effect API on the ID2D1 device context interface. Second, you connect the input bitmap to the effect by calling set input. And optionally, you will set any properties on that effect using set value. Then finally, you render the image using draw image. It's as simple as that. So let's walk through a couple of code examples to look at this in slightly more detail. Let me switch to the demo machine. So in the first example, I'm just using a single effect, the bitmap source effect that I mentioned earlier. And first, I'm going to just run the project, and then so you can see what we are going to produce. So this is a very simple effect. So just to get your toes wet, all it does is use a single effect. So let's go back here. I have set some breakpoints in the code to help us walk through the code. Let me start the example again. So here, I am initializing WIC, Windows Imaging Component, to decode the image off the disk and get it into the imaging pipeline. To do that, I have to create the decoder. And then I go ahead and do that, and then I get the frame of the image. And then I apply a little bit of a format conversion using create format converter to get the pixels ready for D2D. Specifically, I'm converting to the BGRA format. So let's step forward. So once I do that, I have the image stream available for my program. So I go ahead and create the effect, the D2D1 bitmap source effect. And then I set the value or initialize the effect to take in the bitmap stream that was decoded by WIC. Once I do that, my next step is to just simply call draw image, which goes between begin draw and end draw, just like any other drawing commands. And then that's it. And you see the output here. Let's look at a little more interesting example. Let's recreate the drop shadow effect that I showed earlier in the slide. And so once again, let's run this as I was still running the other one. So this is the effect that we want to produce, you saw earlier. So here I'm going to go ahead and run it, and I first create a bitmap using D2D. As I mentioned earlier, a bitmap can come from WIC, or it can be created from D2D or D3D. So here we are creating the bitmap in D2D. And then I'm using the new set target interface to set it to that intermediate bitmap. And then I call begin draw and render the text itself using the draw text call. Once I do that, I go ahead and call set target again and set it to the target bitmap or the bitmap that I'm going to render the final effect. Once that is done, now I'm ready to go to the next step of creating the effects that I need. Oops. So first I create the, go back up here. First I created the shadow effect, and then set its input to the intermediate bitmap we drew earlier. And then I create the affine transform effect and set its input to be the output of the shadow effect. And then finally, I create the composite effect, and it has two inputs. So the first input is the output of the affine transform itself, and then the second input is the original bitmap itself. And then once all that setup is done, I go ahead and call draw image, just like I did in the previous example. Keep hitting the wrong key here. And that goes ahead and draws the image we saw earlier. So let me switch back. So before I move on to custom effects, one point I wanted to make was, in the samples that you saw we used many of the concepts that you can use with modern C++. So for example, comp pointers and the technique to allocate create the effects and all that. So that's something to note as well. So I want to briefly talk about custom effects, and in order to do that, I want to go back to the demo that we saw earlier. So let me switch to the So the ripple effect that I showed earlier is an example of a custom effect that is implemented in this sample. By the way, this sample is available in the Windows SDK that you can download today. So you can download it right now, in fact, and look at all the sources for this entire demonstration that I'm showing here. So the ripple effect is a cool custom effect, but the cooler thing is that I can use the custom effect in combination with other built-in effects. So for example, I can apply saturation here, or combination of saturation and brightness, and then apply the ripple effect on top of that. So this is something that is available for you to use in your applications. We have a large number of built-in effects, but in case they don't meet your needs, or you have a need for creating something that goes beyond that, then custom effects are supported in the platform. There are APIs for implementing custom effects and registering them in your applications. All of the built-in effects that we have included in the platform are all implemented using these APIs as well. Custom effects are relatively straightforward to implement, especially if you have implemented custom solutions before. What you need to do is define the shader program for the effect, implement the methods in the effect interface that the Direct2D effects infrastructure will call, and then hook up any effects properties to the shader itself. You don't need to deal with the details of the D3D runtime or its resources. So for example, you don't have to deal with devices or whatnot. All that is handled for you by the effects infrastructure. Each custom effect can declare metadata about itself. For example, display name, author, category, etc. That may be useful in your own application for if you have user interface that allows the user to pick an effect, for example. As I mentioned, you can mix and match custom effects and built-in effects in the effects graphs to achieve the visual effects that you desire. All of our built-in effects are implemented to support D3D feature level 9 and above. And if you implement custom effects, we recommend that you do the same thing. Dan McLaughlin has a talk tomorrow that has more details on feature levels. And if you are thinking of implementing custom effects, I highly recommend going to that talk as well. So to recap, what you get with Direct2D effects is a foundation for doing high-performance image processing that will enable you to create new scenarios much more easily than you could do before. You can use it to build really cool effects in your applications and delight your users. Make your applications come alive and make Jensen happy. We have included a large number of built-in effects for you to use in your applications. And for some reason, built-in effects, you need to go beyond those built-in effects, then custom effects are supported as well. And there is good support in the platform to implement those and use them with the built-in effects. I'm really looking forward to seeing what you can do with these APIs and the cool effects that you can deliver in your applications. Here are some related sessions that you may want to check out. Some of them have already taken place, so if you haven't had a chance to be at those sessions, I would highly recommend going and viewing the videos of that. Dan's talk, the first one on the list, is tomorrow. And then 381T, which happened this morning, building beautiful and interactive apps with HTML5 and CSS3, has some details on how to program SVG filter effects within HTML and IE. There is documentation and the samples already on the Developer Center. And if you have any questions, I'm here after the talk, so come on by and ask questions. And then I'm also going to be at the Ask the Expert that's starting immediately after this. Many of the folks from our team who are graphics experts are going to be there as well, so happy to take questions there as well. In case you have questions afterwards, we have the forums on the Developer Center where you can post your questions, and we will try to be as responsive as possible and get your questions answered quickly. Thank you for coming, and I hope you find this useful and you are able to use it in your applications.